welcome back. For our next talk, Vic Wang will talk about actual hacking satellites. So for all of you that were wondering in the keynote when we start actually hacking space objects, then now is the time. So please give a very warm round of applause. And just a quick note, we found an iPhone here on track 1. If you're missing an iPhone, then approach us here in the front. Of course, you have to prove that you can unlock it so we can return it to you, so not storm the front. But yeah, just if somebody searches his phone, please approach us. And now, please give a very warm round of applause for our next speaker.
So, hi, I'm happy to be here. And today I'm going to share something about the open source satellite communication protocols and vulnerabilities, and one case study of a journey that's hacking a ground station system. So I would like to introduce myself first. I'm Vic Huang, an independent researcher, and I'm from Taiwan, so it takes like 40 hours from Taiwan to here. And I'm glad I'm still able to speak English because my English is just poor. Okay, anyway, I work in several different domains, and recently I'm working on the satellite domain, which is pretty interesting, and so let's start. So I believe some of you guys have heard the keynote about the Space Security 101, so I will quickly go through this segments. So basically, the satellite service has 4 main segments. User segment, which includes all kind of devices you can access to satellite service. And satellite is in the space segments, which include all kind of space objects. And there is ground station segment, which is the core control of the whole system, or you can say the space systems. And between these 3 different segments, actually communicated by RF radio frequency. So there's one more segment named link segment, which is you transmit the data between different segments. And in case you are not familiar with the satellite itself and what is in the satellite, the internal system. This is the internal systems. You can see in your left-hand side, it's a centralized system with all kind of subsystems that is necessary to operate normally in the space. For example, thermal control and electric supply systems and attitude control system and so on. And in your right-hand side, there's a diagram of standard 2U CubeSat, which is I can say the most compressed kind of satellites, and it's very small. And it only contains the necessary parts. For example, the onboard computers and the payload. The payload here is a kind of the device for mission. For example, an X-ray imager or something, and also antenna and some stuff for the electric supply. And here is the satellite segment and the threads. So basically, let's start from user segments. In our knowledge, there are several malware that are targeting the user segments. And also, in the space segment, which is less discussed in the conference, it's about there could be insecure protocols or unauthorized control or a kind of spoofing, jamming, as I mentioned, is all about the radio frequency attack. And also, it could also happen, the malware attacking the ground stations and all of kind of like traditional infrastructure attack. So let me give you an example. So there is an attack in the 2022 VISAT incidents. That's basically the Russian-related APT groups attack VISAT first they compromised the software center, and then they delivered the malware acid rain to users' router in their home, the cellular routers, and erase the flash memory, then overwrite the junk bytes into the flash memory, and it turns the cellular routers to brick. So the user in Oakland, they couldn't access to the internet at that time. So this is the most famous case of the attacking satellite systems. And I also being inspired by this case, so I start to dig into satellite security. But as an independent researcher, usually I don't have any resource to or connections to the governments or the militaries. So the best chance I can try is the open source or open satellite project. And after like Google, there are a bunch of the open satellite projects on communities or from the universities that's also supported by the government. But the most interesting is they open source their software and some of the hardware that you can check in the GitHub or other like websites. So that's made me a chance to access to this kind of satellite internal protocols. So in this presentation, I will start from the protocol attack in the first case study, and the second study is about the ground stations system attack. The first is the SpaceCan. So SpaceCan is one of the library in the open satellite project LibreCube. And the leaders of the LibreCube are, he works in Taiwan before, actually, and as the members that helped Taiwan launch the first CubeSat. So I believe he's experienced in the satellite developing. So this LibreCube is an open project that aims to create ecosystems of modular components. For example, satellites itself, and also kind of exploration vehicles or something. So they want them to use the same kind of protocols. And basically, they develop their protocols based on the CCSDS and ECSS standards from like NASA and ESA. And they just simplify that kind of standards. So SpaceCan is actually one of the libraries that they simplified, the ECSS 5015C, which is a CAN bus extension protocols for internal communication. And actually, the first time when I realized about the CAN bus is also used in satellites, I'm pretty surprised because most of time I heard about CAN bus in security domain is about like car hacking or something, right? So actually, a CAN bus is also used in satellite and is pretty general, kind of a general integrating CAN bus into the systems. So you can see in your right-hand side, basically is how it work, the CAN bus work in the satellites. So there will be a master, the onboard computer, OBC, and the two buses connect to different electric units. And in your right-hand side, as we mentioned, the SpaceCan is one kind of CAN extension protocol, but it actually is just use the CAN frame to transfer the data of or functions of these protocols. So it should be a kind of L3, layer 3 application, their protocol or something. Then first, when I try to review the code of the SpaceCan, I just found the security design of this protocol is not so good, I would say. So first, and every electric unit connected to the CAN bus will provide a node ID, which is represent who you are or what units you are in the systems. But actually, there's no kind of restriction or authorization mechanism in these systems. So basically, you can just pretend as another node ID in these systems. So basically, you can see in the graph, in the image, that you can have two node 1 at the same time. But in design, it should be unique node ID. So there is a kind of potential spoofing on this system we already know about. And the next is about when I try to do a spoofing on these systems, I have to know about the architecture of this system and how the space can work. So the space CAN in your left-hand side is using CAN frame to transfer data. So the 11 bits is for CAN ID that's designed in space CAN, which means the headers of the packet. And the 8 bytes for the data and used in the CAN frame data field is for data transferring. And there are several different commands that's developed in the space CAN. You can see in your right-hand side. It's about heartbeats or sync the time from the Earth and the universe time. And the most important two functions here are tail command and tail entry. So to be easier understanding, tail command is that the ground station will send a tail command to the satellite, and the satellite should respond the telemetry back to the ground station. Then we can dig into the CAN ID, and in here, the 11 bits of CAN ID, the 4 higher bits in here is kind of a mask of function in the space CAN. And then the 7 lower bits is represent the node ID, like which ID I was, and I send something for some functions to the onboard computer. And in the command execution cycle of space CAN, basically is the controller send the tail command to the nodes, and the nodes can only respond the telemetry back to the controller. So this node that we want to do kind of spoofing, and is basically the most passive role in the whole systems. So how could we do spoof? And after reviewing the functions of the tail command, there is a tail command 3.5, which named housekeeping. So this housekeeping is kind of a maintain mode of the satellite that it will checking the component status. So once the housekeeping is active by the ground station, and then the node can actively send back the telemetry from time to time. And this is one of the few chances that the node will actually actively send the data back to the controller. And then once we can use the duplicated node ID and also the housekeeping is active, then we can do spoofing. Then we can dive into different packet splitting and assembling about how the controller gathering the information and assemble the information. So in here, space can have a mechanism that for the long data, because the data for telemetry, one telemetry might longer than an 8 bytes in the CAN frame. So it divides the long data to 6 bytes and add 2 reserved bytes in the front of the frame. So you can see in your in the bottom that if you have the data from 1 to 14, it will divide as 1 to 6 and 7 to 12, and then add the total frame minus 1 in the first bytes, which means 2. Like totally, there's 3 frames, so there is 2 in the first reserved bytes, and the second one is for frame order, so it starts at 0, so it's like 0, 1, 2. And after the controller receives the mutable frame from the split or you can say separate packets, you'll start to assemble. But how they assemble it is by the logic in your right-hand side. So firstly, you will check the total frame of the frame. So actually, it's the first reserved bytes. And then you will create a buffer for that node ID. And if there is an existing buffer, it means there was a packet that's sent to the controller about this long packet. So, and next, you will assemble the data when the numbers match the total frame. And this mechanism should be fine when the node ID is unique. But in here, in our case, the node ID can be duplicated. So actually, you can ruin the orders of the packet assembling. So let's say if housekeeping function is on and there's no buffer at first, and we have one malicious node ID 1 and one normal node ID 1, which should be happen, right? Shouldn't be happen. So the malicious node ID 1 can send to the incomplete frame at first. So the buffer will be created at the first of the frame. And then when the third frame that's from the normal node ID that's sent to the controller, it will match the condition that total frame equals to 3. And you will start to assemble. By the orders in the second reserved byte. So basically, you can do it like that. If you send the 2 malicious frames at first, you will start to assemble as any kind of orders you want. So in this case, you will be 1 to 6, and depends what kind of order you want. You can just put the random numbers in the second reserved bytes, and you will change to different orders that you want. So that's how we can spoof this kind of internal communications. And what is this important and what is matter if we can manipulate this kind of data? But actually, it's very important because if you can manipulate the data internally and the telemetry is sent back to the ground station, and the operators in the ground station may not know what going to happen, because in this case, I can just ruin the assembling packet and make the data from the normal voltage to a strange voltage, and they may think, oh, what happened, or something bad happened, or something wrong on my satellites, and I have to fix it, and they will do the maybe kind of bad decisions to fix this kind of issue. And this is the first case of the open satellite protocols communication spoofing. And I believe there's more this kind of vulnerabilities, which is kind of basic because it's lack of authentication or other kind of security check, but it is what it is because like most of the open source protocols have this kind of issue. And then after the first case of the in the space segment about the insecure protocols, I would like to introduce the second one about the case that is system beta, which is real like ground station systems. And in 2023, I have a chance to connect with satellite suppliers, and they asked me to try to help them to test their systems. And of course, I signed NDA, and also this content will they already review it, and they remove bunch of the details, but I hope you guys can still enjoy it. So basically, it's a ground station system, and it's a 3-layer systems. So for user interface, it's a web service that's written in Python. And then there's a middleware and a CSP service for directly communicate with the satellites. And for middleware is kind of auth check in the whole systems. So in case you don't know anything about the CSP service, so CSP is kind of it's an open source protocols that you can find it in the GitHub libcsp. So it developed in since 2008, and it's written in C. And also, it's widely used in the satellite industry. And there are known vulnerabilities in this CSP. There were like several buffer overflows on like memory copy functions in the very old systems. And Jay Welbord, which is also famous as a satellite security researcher, he shared about the libcsp has a problem on CRC and HMAC protection implements in Black Hat, I think, US 2023. And then this is the CSP packet format. Basically, you can see the first row is about the headers, and the second row is about data. So the CRC and HMAC in this CSP only protect the data part, but doesn't protect the headers part. And I also find that in the version 2, which they claim they will fix this issue, it's actually, you can bypass it because it will firstly check if the header is included, it will pass the CRC or HMAC verification or not. So if fail, it will just remove the headers part and then verify it again. So basically, it's still no check, no, the issue is not fixed at this time. Okay, so let's go back to the web service. So in here, there are 3 different roles, and I got an engineer account at first. But in this test environment, actually there was no test device or test satellite connect to the whole systems. So basically, almost all of the monitoring tables or kind of log systems or the function that interact with the satellites were dead. So not much I can do. So as a web pen testers, I can just start from the web. So I noticed there is a field that it is a key that it has a restriction about 20 characters length, but actually this restriction is only on the front end. So basically, in the back end, there's no kind of restriction, and you can put any kind of special characters in the key. And this key is also customized by the user themselves. So basically, I just start to do fuzzing on this field. And one of the payload I use is the double breast 7 multiple 7. I think some of you might know what it is. So the normal response might be it just puts the same payload back to the users, but actually the response is embedded inputs. So it triggers a alert in my brain that it could be a SSTI. So SSTI is a server-side template injection, and some of the system might implement this kind of formats that they will firstly render the content in their backend and then respond to the user, which is different from that we normally see in the websites. You have JS and you just call the API and response, and you will try to render on your page. So if you can do the code injections in these kind of systems, the code will actually execute on the back end. And the system is built by the Flask Jinja 2. In the past, I think it's very common in the CTF since the 2015 that James Cattle shared this kind of SSTI research. So basically, the easy case that you can put it double brace something and see the response is different from the payload you put or not. And in 2018, I guess, Jinja 2, they provide a sandbox libraries. So you can just use that sandbox to prevent this kind of attack, because this SSTI will lead to remote code execution. So for Jinja 2 sandbox in the real world, actually it's really common. And when you try to put this kind of payload inside, you will return you 49. But if you try to fetch the object in Python to achieve RCE, you will return that you are not allowed to access this kind of attribute, and it's undefined. But if you still remember, the response of this ground station system is embedded input double breast. So basically, I guess it's they implement their own blacklist on this field. So I just try to bypass this kind of restriction. So you can basically use breadth and percentage to bypass it. And it will represent a kind of logic expression. For example, you can put if 7 multiple 7 equal to 49, if yes, respond true. If not, respond false. And at the moment I tried, I found that the system respond the true on my key field. And then I think, okay, I should get a shell. I should able to get a shell on the systems. So I just fetch the objects in Python. So because sometimes they will customize their Python to remove the dangerous object inside, but actually they didn't. So this is the final reverse shell that I can put in. I can get in the web service. You just have to open a sub process and build sockets and deal with the input output, and then you can get the shell. So after I get a shell, and I start to dump the source code of the web and the database, and I also try to use to directly communicate to the listener, to the middleware. But I found that a lot of errors because seems my key is too long and a bunch of special characters. So the middleware just refused to accept this kind of key because the key is also one of authorization in the API calling. So I have to crack the database and get another account to do more further research on the incoming systems. So now I can, after that, I can normally use the functions in the web, and it will send the request correctly to the listeners that I can see there's a CSV packet there. And so far it's only a SSTI lead to RCE, and nothing I can do more than that besides hacking a website. So what can I do now? Then I try to look back to libcsp, like what kind of functions that might be included in this service, but also it's dangerous. And I found there are two functions in CSP management protocols that provide for use for engineer to debug, I guess. So actually, the peak is for reading the memory address on the satellite, and the poke is overwrite the memory address on the satellite. And it also comment in the source code that they are super dangerous function. You have to know what you are doing while using them. And then I try to find, first I got admin accounts from the database, and then I try to find if there are anything related to the pick and poke function, because they might be not included in this service, but luckily they are. So I found fetch address and overwrite address with the two admin key. I think they have a kind of approval process. That's when you do these kind of things. And then I can, after that, I can write the kind of malicious thing to the satellite by CSP pick and poke. But actually, there were no devices connected to this system at that moment. So I just can only stop here, and I reported the issues. And I think maybe that's it. But after 8 months, they contact to me again. They said, we have fixed these issues, the web issues, so we would like to invite you to test it again. And I'm like, sure, why not? But that time, they only provide me 3 days of access to the systems. And I just asked them, can I get more time than the 3 days? And they refused. At first, they said no. But on this, you want to test our test devices that connected to the test. There's a kind of test satellites connected to that systems. So if I want to test this, they can give me more time to do it. But eventually, they only they gave me 1 more day for testing. And I found that the SSTI is fixed at the website web service, so I need a new shell. And I tried to, I had an admin account this time, so I tried to find is there kind of sensitive or vulnerable functions in admin. And I found one. It's pretty dumb vulnerabilities. I assume that listener is actually connected to CSP, but actually it's not. It's directly binding the IP address to the web service. So there is a very basic command injection that you can use a vertical bar to do the command injection at that function. So basically, I got a new shell here, and then what I want to do is interact with the device, the satellite, right? So I try to find the vulnerabilities in the middleware and CSP service because there are the real service that directly connect and interact with the satellites. But unfortunately, I couldn't find any kind of vulnerabilities on this service. So next, I still want to test the device, and it becomes a pure black box device testings. And I cannot touch the device, and there's no kind of camera for me to see like what's going on if I send the command. So basically, what can I do is first I tried like satellite OSINTs, and basically how can we do it is just we Google the satellites, and there will be a detailed spec, and you can follow the detailed spec to find like what kind of MCU is using in the satellites and so on. But in this case, I have zero information related to the device, so it won't work on this case. And also the blind test, probably I can use CSP pick and poke to observe the system memories, but it will take a very, very long time. So I came out that probably I can do the source code review on the website first and see if there's kind of hard-coded credentials or memory address or any kind of information inside. And there are some different, there are like some of the important admin functions. And the first is the IP address binding. As I mentioned, I got a shell on this command injection vulnerability on this. And then there are firmware updates that can update the firmware to the certain slot and fetch and overwrite address, which is the lower base of the flexible memory operation. So other function also built on this function. And there is a factory recovery for the satellites, and it will change the blue flag to a certain value, and obviously it's a fixed value. And the last is the static monitoring. That's the system will fetch the data from the flash memories and then display it on the website. And then I have, besides this, I have nothing, and I cannot find the vulnerabilities on middleware. Like, what can I do? So I just realized that I can just use a listener because I don't have to care about how they transfer the data. I only care about how they interact with the satellites. So I started to observe the listeners by while using these functions and try to find if I can find like a kind of matching results on the internet in the Google OSINT, but there was no like similar kind of MCU they use. But actually, I find something more interesting. The value the value of these functions are fixed in the CSV traffic. So basically, you can just observe the factory recovery to know the bootloaders, like which flag it will turn to factory recovery. And also, for firmware update, it will start from the slot that's used for firmware updates, the memory address. And also, the static monitoring can allow me to see the running slot A, the part of memories that I can access. So now we know about the bootloaders, the boot flags, and the slots A and for the running binary, and the slot B for the firmware update. And there should be a slot C for factory recovery. And then I try to attack with these several different attack mode. The first, I would like to try live patching the firmware in slot 8, and probably I can execute my code in the slot 8. And then the second one might be put the malicious payload in the RAIN, probably in the slot C, but I have to find a way to jump to the memories that I control, and then I can execute my code. And the third way is you can just upload the malicious binary file to slot B as a firmware update, and then rewrite the boot flag and switch the boot loading process to the slot B. That's you also execute my code. And in terms of denial of service, it's much more easier. That's you can just overwrite the boot flag to any kind of a junk data or junk value, and you will turn the cell line to a brick. Or you can just overwrite like firmware update slot B, and then to overwrite the flash memory just like the VI set incidents. And then if we can also switch the boot loading to the slot B, and so it will, the cell line will also become a brick. And in the first attempt of live patchings, I failed a lot of times, and I crash and wait for reboot or wait for like factory recovery. So I just failed. I cannot find a way to live patching the firmwares in the slot 8. So, and I also can because I don't have the firmware, so it's very hard for me to find a place that the process will able to inject a memory address, and that memory address is what I can control. So what I tried basically is upload the malicious binary file to slot B, and also the denial of service about overwriting the boot loading process. But I was so afraid of breaking the test device because I guess it's 10,000 euro devices. So I just contact with the developers. Could you try these tricks, and then just tell me the result if it's valid or not, and then I don't have to break your device. And after the confirmation from the developers, they said the orange method is valid. So let's start from the whole journey. Go through the whole journey from the web. So we have two kind of vulnerabilities on the web service, and after the code review and database dump, and we can observe the CSP's listener to observe a CSP traffic, and then we can analyze what kind of information is hard-coded in the middleware and CSP service, and which can lead to the boot loading process manipulations, and also kind of update the malicious firmware, and then switch the boot loading process to the certain slot. So that's how I hack this ground station systems from web to RC and denial of service on the satellite. And thank you. And there's some takeaways that if you go through the whole journey with me till now, so you can see that satellite attack no matter in the protocol side or that kind of ground station side, it's like super basic web attack and protocol analyze and kind of dump stupid malware or just overwrites something in the bootloader. So it's not so hard. It's much easier than you can imagine. And also for the hackers. And some of the satellite systems are lack of the security design. You can see in the protocols or even in the websites. And I communicate with their developers, and they said the power consumption and the temperature control are still the first priority of when they design the systems. So they don't even care about if it's secure or not. And also we can see that a lot of problem is on no internal validation or any other kind of protections on the sensitive process or data. And also, the last I want to mention is that ground station is basically, if you take over the ground station, you can control the whole space systems. So, but the vulnerabilities I mentioned in this ground station hacking journey is so basic. So if you are one part of this industry, please to find some the third party to do red teaming or penetration testing or product security assessments for this kind of critical systems, and it will help to secure the infrastructure. Thank you for your attention.
Yeah, thank you very much for this very interesting talk. Are there any questions from the audience? Otherwise, I have maybe one. I was wondering the whole time, now you attacked the ground station, which is pretty interesting because I would never imagine that something like this is written in Python, at least like on the web layer. But did you also at some point think about direct attacking the link between the satellite and the ground station? Like, for example, building your own satellite dish and see what kind of modulation and wireless protocol is used there? Is there any authentication there? Because basically you're now relying on this libCSP to do the communication to the satellite. Could it be possible to do that from like the hacker's device?
Basically, you're talking about the signal attack, right? So there were several cases about attacker tried to replay the tell command, and they try to move next to the ground station and try to record the signal and replay the signal and to see what happens on the satellites. But it's kind of like old school stuff, because for now they enforce the link segments that they will try to obfuscate or add something like kind of sort things in the communication of the radio signal. So you can see there's a bunch of research in Iridium's communication protocols in the signal that they can intercept the signal and try to know like what it's doing inside. So in the real world, the attack method, as you mentioned, it could happen, but it's based on if someone has cracked the signal communication method.
Yeah, so there's really a lot of reverse engineering to be done there, right?
Yeah.
All right. Now, any questions from the audience?
And I also want to add on about why I didn't try to do a signal attack, because in my country, I'm not allowed to emit the signal they kind of RF, or I are just against the law, so I just prevent to do that kind of thing.
All right, if there are not any more questions, feel free to approach the speaker afterwards, and now give another round of applause and then enjoy the lunch. Thank you.